Hello and welcome. In this video, I'll be showing you how to factorize expressions. Now, these expressions we start with are not quadratic expressions. So you just have to look out for a highest common factor, write it outside the bracket, and then try to divide each term by the highest common factor. So in this case, 3 is the highest common factor. So we write 3 and we ask ourselves 3 times what would have given us 3x. Obviously, it would have to be x. And then we ask ourselves 3 times what number or would give us 9. 3 times another 3 would give us 9. You could think of it as this 9 that we had, we divided it by 3, the 3 outside the bracket to get the 3 inside the bracket. This expression, we divided it, the first term was 3x. We divided it by highest common factor and we ended up with the x that we put inside the bracket. So let's look at some more examples. This next example, x is the highest common factor. So you write x outside the bracket. Then you ask yourself, x times what value will give me x squared? It would have to be another x to give us this x squared. Or you could say I'm dividing by highest common factor. Each of these terms, if divided by the highest common factor, will give you this x inside the bracket, and 5x divided by x will give us a negative 5 because of the sign. So that's how we factorize that. So it might look a little messy, but I'll wipe off my working out. But that's what's going on behind the scenes. So this next term, think what's the highest common factor, and then unpause the video, play the video, and check your answers with me. Video and have a go at this, and then play the video. Okay, I hope you found the highest common factor is 3xy. The factorized version is so. Alright, now we just looking at expanding brackets because we're gonna have to factorize the answer. We know that from this multiplication we would have got minus 5x in the middle for the middle term, and also 3x when we multiply these two terms with each other. So that's how we ended up with a minus 2x in the middle of this expression. Alright, notice the sign belongs to this term in the middle. So when you have to factorize this expression, you are looking for the factors of minus 15 that add up to, so minus 15 is product of two terms, product of, let's call this a and b, the numbers that we put inside, and this is the sum. Sum is of a and b is minus 2. Okay, so if you had to work backwards here, you would say minus 15. What are factors of minus 15? It could be plus or minus 15, 1 times 15, or negative sign. So you can distribute the signs like so. If you take minus 15, you have to take positive 1, and if you take 1, minus 15. But the sum doesn't add up to minus 2, because we either get minus 14 or we would have got positive 14. So that doesn't help us. We look for other factors of minus 15. So you can distribute the signs like so, and you notice that minus 5 plus 3 adds up to minus 2. That's why the factorized version, you first write the first x's inside the bracket. So if we are factorizing this, first you write, just open up two brackets here. You put x and x in at the front because we have a x square here. So x square is split up like so. Then you say, all right, the factors that I found was a plus 3 and a minus 5. So it doesn't matter whether you write plus 3 here in the first bracket or plus 3 in the second bracket, as long as you multiply this bracket, you end up with this line as the answer. So let's look at some other examples. In this case, we say the numbers that have to go inside the bracket have to give us positive 12. So their product is a positive 12, and they have to add up to minus 7. So sum of those two numbers is equals to negative 7. So you write all the factors of 12 for yourself, and you think, all right, which of these pairs will give me a negative 7? It's not hard to spot that minus 3 and minus 4 will give you 7. So you open up two brackets and you put minus 3 into next to one of the x's and minus 4 next to the other x. In this case, once again, those two numbers inside the bracket have to multiply to 16 and add up to 10. So what are the factors of 16 that add up to 10? 1 and 16, or 2 and 8, or negative 2 and negative 8. Now, it's not hard to notice that all of these lines actually give us a 16, but the ones that add up to 10 is only one pair. So this pair, plus 2 and plus 8, add up to 10. So you put them inside the bracket like so. All right, so pause the video, have a good discussion, and then check your answer with me. We see these factors of minus 20 are all these pairs that I've laid out here for you. So the sum have to be a minus 1 because there is an invisible 1. Although in algebra we don't write it, the minus sign also goes with the 1. So it's a minus 1. Which of those pairs add up to a minus 1? All right, I hope you spotted it. It's plus 4 and minus 5. So we put those numbers inside the bracket like so. All right, so this is the numbers that A, B, and C are the coefficients of x square, x, and the constant. So I've made another video how to factorize with using a calculator. You do need to check your answer and show working out. And also when you find use your calculator, your calculator will tell you, for example, x is and x is. So how can you go and put those answers from your calculator back into brackets? So that's kind of cheating, but that's one way of finding the answer. And you are allowed to use a calculator to factorize expressions like so. So if you think about it, uh, so let's just solve this problem. The answer is 2 and 4. So your calculator would have actually given you the negative solution. What does your calculator do is that he takes it out of the brackets and solves it for you, sets it equal to 0. So first thing you do is you say you collect the number next to the x, so you have to add 2 to both sides. So then you write x plus 2, and here you put a bracket around it. Now this x minus 4, with you add 4 to both sides of the equation, so you write x plus 4, and that's making it equal to 0. So basically what we are doing is we first write it as something equal to 0, then we can put the bracket around it, and these two products will multiply out to give you that answer there, the factor, the expression there. All right, so let's look at this expression here. In this expression, this is called difference of two squares, because this kind of a quadratic, we only have x squared and a constant, which is minus a square number, a negative of a square number. So you can think of it, what is the square root of 25? Square root of 25 is plus 5 and minus 5. All right. So the fact that there is no middle term, there is no x to the power of 1 is that there was a plus 5 and a minus 5 that when we added them together, they cancelled away to give us 0x to the power of 1. So when you have to factorize difference of two squares, you look out for the number at the end and you try to find its square root. Then you open up two brackets. You say in the first bracket, the sign of x squared is positive, so I don't need to write anything in front of x here. So then I'll put a minus 5 and a plus 5. The order doesn't matter. You could put a minus 5 in the first bracket and plus 5 in the second bracket. Now I'll show you another example. You might see a question like so. What's the difference between this expression and the one above is that you have a coefficient of 9 here. Now this 9 is positive, so you also need to look out for the square root of this expression here. The square root of 9x squared is plus or minus 3x, but you only take the positive value for this because the 9 is positive. So when you had to factorize this, you would write as one bracket with positive 3x and another one. Let me write them below it. So you write plus 3x, leave a gap, and plus 3x, leave a gap. You put a plus 5 and a minus 5 next to it, like so. Alright, so that's the factorized version of this line here. Alright, so I told you the fact that there is no middle term is because when we multiply out these brackets, plus 5x and minus 5x cancel each other out. Alright, so let's look at another example. In this case, as you see, you have 4 and 9 as coefficients of x squared and y squared. So actually it's a minus 9. So the 2x and 2x go in front of each bracket, and then you're going to say factorize the square root of 9 is 3, plus and minus 3. So the sign of 3 has to change because of the minus 9 there. Alright, pause the video, have a go at these questions. Last one is quite challenging, but you should be able to do it after some thinking. So pause the video, have a go, and then I'll show you the answers. I hope you've had a go at these questions. So you could even simplify that expression there. And in this case, you think of 81 as 9 squared, and the second bracket is in as a squared form anyway. So when we take its square root, we will have such an answer. So you can simplify what's inside the bracket. Combining 9 and minus 2, you can write it as plus 7. Combining 9 and minus a minus 2 gives us a plus 2 with such expression. Now that we've had a go at this question, some expressions may not have a square root. So this 45 here doesn't have a square root. So don't be fooled. You cannot always write these expressions as difference of two squares. In our case, actually the highest common factor of the numbers is a 5. So first you factorize a 5 out of this expression. Then it becomes simpler and evident to you that then the square root of 9 is 3. Then you write 5 times x plus 3 and x minus 3. So don't be fooled. If you cannot factorize, you cannot take the square root of the second term. Don't write it as 5x, a square root of 5x. This doesn't make sense. This is not the factorized form. Writing square roots inside the bracket doesn't help us. So don't go down that route. Look out for the highest common factor of the numbers, and this is the correct way of doing it. Alright, so now here we're going to look at factorizing harder quadratic equations. There are more than one possible way of doing it. I'll show you the long-winded method, and then I'll show you a quick way of figuring it out. So you can think of this 2 and 3 this coefficient of 2 makes it harder for us to factorize it. So you say multiples of multiplying 2 and 3 will give us 6. So actually I'm going to look out for factors of 6 that add up to 7. Now 2 and 3 don't help us because their sum is not a 7. But thank you very much. Thank you. 6 and 1 do add up to 7. So then we're gonna split this 7x up as 6x and 1x. Okay, now it doesn't matter whether I'll show you after I've gone through this, whether you write x first or 3x, 6x next. So then you look at these, put them in different colors because the red section is where you factorize separately. This imaginary wall I've put in the middle is because we only factorizing two terms at a time. The highest common factor of 2x squared and 6x is a 2x, and the highest common factor of x and 3 is just the 1. So then we write it like so. And what you notice is that these two dark brackets are the same. So we collect 2x plus 1 inside one bracket, and we write it as 2x plus 1. And the other the x plus 3, you only need to write once. All right. So what if you didn't write it and you wrote this another way? I'll show you. What if you wrote 2x squared and you wrote a plus x here and then a plus 6x and plus 3 here and your imaginary wall is here? Then factorizing this expression here, the highest common factor is only an x. So inside your bracket you'll end up with 2x plus 1. Now, in this form, the highest common factor is a plus 3. So when we factorize that out, we'll have 2x plus 1. Notice again, you end up with two brackets that are exactly the same. So you collect these two terms inside one bracket, you write x plus 3 and 2x plus 1. What's the difference between this answer and the answer we found earlier? Well, only the order of the brackets changed. This bracket is exactly like that, and this bracket is exactly that. So only the order of the brackets changed. So as if by magic, if your expression is factorizable and you've been asked to factorize it, it will work out nicely. Notice that we multiplied 2 by 3. So this is the extra step that we need to add into our calculations. Previously, we were looking only for factors of the last term because we had a 1 in front of our x squared in all the previous examples. So in this case, 1 multiplied by that 3 would have left it unchanged. That's why we didn't bother multiplying 1 by anything. But now we do that. All right, have a go at the next example and think and, and then compare your answer with me. And then I'll show you yet another way of finding the solution here. So I hope you've had a go at the second example here. 3 times 10 is 30. So we're going to look for factors of 30 that add up to 17. You write out most of the factors for 30 and you will come across at least one. 5 and 6 don't add up to 17. So forget about 5 and 6. 10 and 3 don't add up to 17. So forget about that. 15 and 2 do multiply to 30 and do add up to 17. All right, thank you. The crowd is overwhelmed by my intelligence. So there you go. So what we're going to do is split up that 17x into 15x and 2x, like so. Now I said it doesn't matter which way you put these two numbers or these two sums. Once you split them up, you factorize the first two terms and the second pair together. The highest common factor of 3x squared and 15x is 3x, and the highest common factor of 2x and 10 is 2. So then you collect 3x plus 2 in one bracket, and 5x plus 5 goes in the second bracket. Alright, so I hope you've enjoyed that. Let's see yet another way of solving these kind of harder problems, factorizing this kind of a question. All right, this second method is an unofficial method which involves multiplying this 2 by 15, but this time we actually change the question and we rewrite it as removing the 2 here. So multiplying 2 by 15 will give us plus 30 at the end. We change the question to x squared plus 30 at the end of the question. So I remove that 2 now, but I leave the 11x as it is. Now we go ahead and pretend there is a 1 here, and we're simply looking for factors of 30 that add up to 11. We know that 5 and 6 work out perfectly here. So we put the x here and x here. And notice I'm not writing anything in front of x yet. I put a 5 here and 6 here because they multiply to 30 and add up to 11. Now, because here I took that 2 and multiplied by 15, my work is not done. The next step is to divide by the fact that I multiply this number factor that I multiplied by. I multiplied 15 by 2, so now I need to divide by 2. This 5 doesn't divide by 2, but the 6 does. Because 5 doesn't divide by 2, I simply put the 2 in front of that x and write 2x plus 5. What I'm doing is that I'm just rewriting this multiplication of multiplying these two terms by 2. And because the 6 divided by 2 gives us a round number 3, we can just write x plus 3 in the next bracket. Now this is the factorized form. We have finished with factorizing that. Now you might like to use this method in your working out. That's fine. The correct answer will be given with both methods. I'll show you the correct answer. Alright, I hope you copy this. You can pause the video and copy what happened here, and I'll show you the other way to solve it. Alright, so we ended up with exactly the same answer that would have worked the other way. So it's up to you to choose which method you like to choose. Again, in this method, my way is to say 5 needs to be multiplied by minus 14. So we write here 33x. 5 times 14 is 70, but we keep the negative sign because we're multiplying 5 by a negative number. So now we are looking for factors of 17 that adds up to negative 70 that add up to negative 33. Now 70 is made up of 7 times 10 plus minus sign, and we can say it's made up of 5 and 14, which don't add up to 33. What about 28? No, 28 is another factor of 70. What are the factors of negative 70 that add up to 33? Pause the video, have a go. If you go at, I started again. So if you have a go at this question, you end up with writing factors of negative 70, and you notice is that 2 and 35, or rather 2 times negative 35 add up to negative 33. So then you pick out the, the pair that will help us. You can write it like so. You factorize each side of the imaginary wall, factorizing these two pairs and factorizing these two terms, and then finally collecting the brackets like so. Okay, so I hope you found this video helpful. I'll see you in the next few examples.